Broadcast is now starting. All attendees are in listen-only mode.
Good morning and welcome to the August Pacific Northwest DEWS Drought and Climate Outlook webinar. Thank you for joining us this morning. My name is Holly Prindeville and I'm the coordinator for the USDA Northwest Climate Hub. This bi-monthly webinar series is hosted by NIDIS, CERC, and the Northwest Climate Hub. It's designed to provide stakeholders in the Northwest with timely drought and climate information. Each webinar is tailored to reflect recent, current, and forecasted conditions and climatic events, and also includes discussions of observed impacts and other relevant updates across the region. This webinar is being recorded, and the recording will be posted on drought.gov later this week. Note today's webinar, you'll have an opportunity to provide us feedback to help improve the webinar series. So please take a moment at the end of the webinar to respond to the survey. Today's speakers include Nicholas Bunn, the state climatologist for Washington, who will present the climate recap and current conditions. Then Jeremy Wolf with the National Weather Service Spokane Forecast Office will present the climate outlook. Next, we have Joseph Bunn from Washington State University, who will present on air quality forecasting for the Pacific Northwest. And finally, Dave Peterson with the University of Washington will present a synthesis of scientific information on climate change effects of fire regimes and vegetation in the Northwest. Please use the chat box to ask any questions during the presentations. We will get to those during the question and answer period after all of the presentations. Before we move into the presentations, I'll briefly highlight the partners who make this webinar series happen. The Pacific Northwest Climate Impacts Research Consortium, or CERC, is a climate science to climate action team funded by the National Oceanic and Atmospheric Administration Regional Integrated Sciences and Assessments Program. CERC supports communities, policymakers, and resource managers in Oregon, Washington, Idaho, and Western Montana as they work to adapt to changing climate by transforming the latest climate science into data, into usable knowledge. The USDA Northwest Climate Hub, we provide science-based information and region-specific technologies to help agricultural and natural resource managers with climate-informed decision-making. And next, Britt Parker could not be with us, so I will give an overview of NIDIS, the National Integrated Drought Information System. NIDIS's mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS wants to improve our understanding of how and why droughts affect society, the economy, and the environment, and to improve accessibility and dissemination and use of early warning information for drought risk management. NIDIS's approach to achieve that goal is to build the foundation of the national DEWS through the development of regional DEWS, where networks of partners and stakeholders share information and actions to help communities cope with drought. While the ultimate goal of the National Early Warning System, we recognize that impacts and early warning information differ across the region, so each DEWS has many of the same base ingredients, though ultimately have their own flavor to reflect the needs of the region. The Pacific Northwest Drought Early Warning System, or DEWS, was officially launched in February 2016, and the strategic plan is available on drought.gov. They do plan on updating with a new version here to be released soon. Please mark your calendars for the next DEWS webinar, which will be the 26th of October. To help facilitate our early warning system, more precipitation observations are needed, so we encourage each of you to collect your own precipitation data using COCORAS, the Community Collaborative Rain, Hail, Snow Network. This is a unique, nonprofit, community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, being rain, hail, and snow, as well as condition reporting. Observations by COCORAS observers of precipitation events and the lack of precipitation are important events to capture and improve the understanding of weather. If you would like to volunteer, you can check out the website here or reach out to your local COCORAS coordinator for each of the states are listed. And now we will turn to Nick Bunn for the climate recap.
Hello, everyone. Nick Bunn here, and welcome. I'm flattered to be able to provide this recap, and you should be able to see my screen now. Let me know if otherwise. Sounds okay? So,
yeah.
All right, very good. So, as part of the office, Karen Babaka sometimes does some of these things. She's on maternity leave, but her spirit is with us. Going to start off with just the last 5 full months, what the temperature and precipitation has been relative to normal across much of the Northwest. And there on the left is temperature, the blue colors referring to cooler than normal conditions March through July. On the right is precipitation in a percentile way, showing where the greens are wetter than normal. And one thing I'm going to be coming back to with all these maps is the difference between west and east, where in general, depending, no matter how far back you look in this past few months, it's been kind of warm and dry in the west and cooler and wetter relative to normal in the east. So if we go to the just one little thing that I thought was kind of interesting, if we compare 2019 with 2020 for that same period, 5 months, March through July, this is just for temperature. The scales are different. Got these maps in the Westwide Drought Tracker, but look how similar the patterns were in terms of temperature anomalies in 2019 on the left versus 2020 on the right. And even the magnitudes taking into account the scales are very similar. So just kind of, you know, very interesting, I think. All right. So let's look a little bit, you know, more recently, last 60 days as of last week, and temperature on the left, precipitation on the right, and that is the dryness in the western part of the Pacific Northwest, even more striking with the precipitation percentiles in the many places less than the 10% sort of range. And then for the Pacific Northwest as a whole, and here just looking at the month of July, we had less than half the usual rain in the usual, and obviously the typically dry period. From a humidity point of view, this parameter here, the mean daily vapor pressure deficit, this is for 60 days. Essentially, the browner the color, the drier it is relative to normal. And so across the Pacific Northwest, especially Washington, Oregon, pretty typical, a little bit wetter than normal in Idaho, western Montana. And what I think is kind of interesting here is that there's an overall upward trend in humidity in the summer in the Pacific Northwest. And so that Washington and Oregon were near normal. It shows you kind of relative to recent years, it's actually been kind of on the dry side in terms of the atmospheric humidity. Some other measures here I like to keep track of. On the left is the total moisture percentile, basically the combination of soil moisture and snowpack. Of course, there's not much snow around except for on the very highest volcanoes and so forth. But again, that's the same message of for the most part, it's kind of drier in the west and more moist conditions in the eastern part of the Pacific Northwest. The right plot shows stream flows of 28-day averages, with the green colors showing kind of in the middle of the road range. And this reflects that in much of the Pacific Northwest that, you know, our snowpacks were pretty decent. And actually the stream flows, there are some that are lower than normal, but for the most part, we're in a kind of very typical range. From a reservoir perspective, that again, for much of the Northwest and here, focusing on just the Bureau of Rec reservoirs, but that information easy to get my mitts on. Most of the large watersheds are in pretty decent shapes in terms of the reservoir storage. There's a couple of notable exceptions in the state of Oregon here, the Deschutes. You can see from these teacup sort of ways of portraying that there's some big reservoirs that are mostly empty. Now, to be sure, I don't know exactly where they typically are this time of year, but this seems to me that kind of showing that obviously there's some places that are missing some water. How this all come about, here's a 500 millibar geopotential height anomaly map for the 60 days that I was showing the maps of a couple of minutes ago. And what it shows with lower heights to the north over the Pacific and higher heights offshore of Oregon, enhanced westerly flow coming off the Pacific, but mostly into BC, and then kind of a implied northwesterly flow anomaly over the Pacific Northwest that delivered cooler air into Idaho and Western Washington. But really what this pattern implies is a reduction in the flow of moisture from the desert Southwest, and they've had a really suppressed monsoon down there. And moreover, we of those dregs of the moisture, we haven't gotten much into Washington and Oregon. All right. So just very briefly, some of the impacts. This is a picture, I know mostly what's happening in Washington State, of a vineyard near the mouth of the Columbia, or near where the Snake comes into the Columbia. Picture of the vineyard. I don't know what kind of grapes are being irrigated there, tongue in cheek, but it just shows the contrast between the irrigated parts of the landscape and the non-irrigated parts. And at least in much of the Northwest, not all of it, and certainly not all of Oregon, the water supplies are okay, even though the landscape is that's not irrigated is dried out. The big fires are in Northern California, of course, but we've had some, at least recently, in the Pacific Northwest. This is a scene from Yakima of a brush fire that occurred there a little over a week ago. But overall, our acreage is down in the Pacific Northwest in fires, especially relative to 2017, 2018. And so that's a real difference from Northern California. To be more precise, I just looked up this morning, I think this is right, about 50,000 acres have burned in Washington State, which is on the low side. Depending where you look, and I can't figure out the discrepancy here, either about 40,000 acres or 74,000 acres in Oregon. And while they're by this map that I made reproduced last week, where the flames show where the larger fires have been or are, and the little pink sections show the areas that have burned. The little black and squares and purple squares show very minor fires. And so there have been some fires around, but again, nothing like what has been going on in Northern California. All right. All that comes together, of course, in the U.S. Drought Monitor. And again, kind of drier in the west. More moist in the east, and Oregon is in the toughest shape, with the only parts of the Northwest that are in extreme drought, and much of the state also in the D2 category. So just to sum up and hand it off to my man Jeremy, kind of on the warm side and definitely on the dry side in much of the western part of the Pacific Northwest, with the problem areas being much of Oregon and the kind of east slopes of the Washington Cascades. And You know, the real problems here are in portions of Oregon. And with that, I'll turn it over to Jeremy.
Thanks for the climate recap, Nick. Next, we'll have the climate outlook from Jeremy Wolf. And in the chat box are various links to some of the resources being shared if you're interested in those.
Okay, everybody should hear me. I just unmuted myself and I got my slide up here. So let's get into it. So the things I'm going to talk about is just the smoke outlook as we go through the rest of the month, as we see a pattern change coming up here. And then that'll segue into the September fire outlook. And then we'll shift into ENSO and the fall and winter outlooks from the Climate Prediction Center. And then I'll end with just a couple slides on the drought outlook and the latest flood outlook. Okay, so here was the satellite loop from yesterday, just showing all the smoke that was across Oregon, California, moving up into central and southern parts of Idaho and western Montana. And as I go forward to the next slide here, which is showing the air quality as of yesterday, it was showing air quality across western Oregon, Washington, and North Idaho was looking pretty good. But then as you went south into central and south central Oregon, into Idaho and southwest Montana, that's where there have been greater impacts from the smoke in terms of air quality. And let's see, whoops, going the wrong way there. Sorry about that. Looking at the weather pattern, this is for today. We're seeing a prevailing southwest flow. So a lot of the smoke that's from the California and Oregon fires is being transported to the northeast, which is why those areas are seeing the worst air quality in terms of smoke impacts. But we're going to be seeing the pattern change. This is for August 29th. And we're seeing a low moving into Western Canada. And that's going to switch our wind regime around. Instead of a southwest orientation, we're going to start to see more of a west to northwest orientation. And by the time we get to the end of the month, this is for the 31st, this model projection is showing we're going to see winds coming out of the north across the region. So in terms of air quality, you know, we're going to be seeing a change in the winds. So a lot of the California and Oregon smoke, instead of it being transported towards the northeast like it is now, we're going to be seeing a shift towards more of a north wind trajectory. So I just wanted to put that out there that by the time we get to the end of the month, you know, we will be seeing a change in the winds, which will ultimately impact you know, the smoke transport across the region. All right, so going into the September fire outlook, as Nick showed, it's been very dry over the past 60 days. And with the dry soils, the fire potential across the region, across Washington, Oregon, Idaho, and Montana is near to above normal. So that'll be something that we'll be keeping an eye on as we go into next month. Now, switching gears to ENSO, the Climate Prediction Center has issued a La Niña watch. Currently, ENSO neutral conditions are present, and the tropical atmospheric circulation is consistent with ENSO neutral. But with the sea surface temperatures in the central and eastern equatorial Pacific cooling, the current forecast is for a 60% chance of La Niña developing for this fall and continuing through the winter, where the odds just are similar. The official odds there are 55%. Here is the ONI. This is a how the sea surface temperatures, kind of an index where a 3-month average gets calculated. And in that Niño 3.4 region, which I'll show you here in a little bit where that's located. But since 2008, you'll see periods of La Nina conditions, which are in the blue, neutral conditions, which are in the gray, and El Nino conditions, which are in the red. And last winter, we were in a borderline weak El Nino winter. But you can see the latest reading here. This is for May, June, July average. The average was at minus 0.2, so it's starting to cool off. And if we look at the recent evolution of those sea surface temperatures, you can see that warm water in the central and eastern equatorial Pacific during last winter and spring. But since May of 2020, you can see that there has been cooling taking place in that area. And if we look at the current Niño region departures, this is just the weekly value. So you can see the Niño 3.4 region, the latest reading was minus 0.5. And so we're looking at this graphic right here, the 3.4. And you can see the recent trends towards the cooling conditions. And this is looking at it just across the whole Pacific Basin over the last month, the average sea surface temperature anomalies. And you can see the below normal readings across the central and eastern equatorial Pacific during that period, generally east of the dateline there. And then this next graphic, we're looking at the upper ocean heat content anomalies for the central and eastern Pacific. To me, this is a little more telling because instead of looking at just the surface anomalies, you're looking at a bit of a deeper layer. And you can see the cooling that took place in May and June. There was a slight rebound in July, but you can see the trend towards the cooling conditions again over the past month or so. So here are the Climate Prediction Center and IRI probabilistic ENSO outlook. So if we look at these, the blue bar chart here, the blue, this is for the La Nina forecast probability. You can see how it peaks in the October, November, December period at 60% and then starts to gradually drop off as we go in towards the latter part of the winter and spring. And here is a set of model predictions, the latest predictions from various models. And here's the observed, and then here's the forecast. And you can see they're kind of in two clusters here. There are some clusters that are showing that the La Nina will fade and that we will not have a La Nina as we go into the fall and winter. But there's a greater cluster that is showing a cooling trend as we go into the fall. And anything below minus 0.5 is considered La Nina if it maintains itself for 5 consecutive months. And so you can see that that's what a lot of those members are forecasting. And given the recent trends towards the cooling waters, I believe that probably this cluster down here has a better chance of verifying versus the ones way up here, given the recent trends in sea surface temperatures. All right, jumping ahead now to the outlooks from the Climate Prediction Center for September, showing some elevated odds of warmer than normal conditions, and for precipitation, equal chances, which means, no clear signal for most of the area, with some slightly elevated odds towards southern Oregon and Idaho of drier than normal conditions. And for the 3-month temperature for September, October, November, slightly to moderately elevated odds of warmer than normal. And for precipitation, you can see some elevated odds of wetter than normal conditions over the northern parts of the area and equal chances over the southern parts. And then as we go into the winter outlooks, equal chances for temperatures and slightly elevated odds of wetter than normal conditions. So what typically happens in a La Nina year? Typically, we see high pressure set up over the eastern Pacific which sends the jet stream into the region, giving us cooler and wetter conditions. But the key word here is that it's a variable jet stream. Every La Niña winter is different. So while this tends to be the general pattern, we tend to see quite a bit of fluctuations in La Niña years, which I'll show here in just a minute. These are the temperature anomalies that tend to occur in combination with recent temperature trends. And you can see for November, December, January, we tend to see temperatures that are around normal for those 3 months, with the frequency showing no high frequency. So that tells me, you know, don't expect any big anomalies during those 3 months. But then as you get into towards the later winter and going into spring, there tends to be a higher frequency here, shown by the oranges, of colder than normal temperatures. So the anomalies with La Niña tend to be more pronounced as we go late winter and spring. And for snowfall anomalies, we see a similar trend with some October, November, December, showing a slight frequency of above normal snowfall, mainly up in the mountains and western Montana. But then as we get into the later winter and spring months, a tendency for above normal snowfall across the region, with a fairly high frequency of that across all of the region. But this is for all La Niña years, regardless of the strength of La Niña. Now for the weak La Niña, this is for precipitation maps. And I just wanted to highlight, this goes all the way back to 1950, but you can see anything in the oranges are drier than normal. And when you get into the blues and greens, such as 2005-06, indicates wetter than normal. You can see a high amount of variability that tends to occur during those winter months, which is tied to that jet stream that I was talking about, how it tends to fluctuate, and that not all La Niña winters are the same. All right, so the last two slides here are the drought outlook, and because of the increased odds of wetter than normal conditions for September through October, the outlook does call for the potential, at least, of seeing some relief across central Washington and western Oregon, but for persisting drought across southern Oregon and parts of Idaho. But like I said, there tends to be a lot of variability as we go into the fall with La Niñas, and the odds are only slightly elevated at this point for the wetter than normal conditions, so I wouldn't put a ton of confidence into this at this point, but we'll see how that shapes up. And then lastly, the flood potential outlook is showing generally we don't tend to have much flooding in the fall, except for potentially on the west side, and there are some probabilities there showing a chance for some flooding on a few gauges that are on the west side. And again, this is through December 1st. All right, so summary, we're looking at a pattern shift occurring this week as we transition the northwest flow, which can have implications for smoke transport, near to above normal fire potential in summer. We've got the La Niña watch with the tendency in the outlooks, the side towards wetter than normal conditions and the temperatures gradually dropping off, and the drought forecast, which I just alluded to, in the low flood risk. So I will leave it at that.
Thank you, Jeremy, for the climate outlook. Now we will turn to Joseph Bunn. We can see your screen, but it looks like you are muted, Joseph.
Hello, you can hear me?
Yes.
Okay, great. Okay, so I was asked to present about our air quality forecasting work. We have been developing and operating a system called Air Pact for something like 2 decades. Acronym Air Pact, Air Indicator Report for public access and community tracking or something like that. Okay, and I'm at the Lab for Atmospheric Research and Washington State University, and a lot of people have worked on this over the years. Okay, so I'm going to tell you what Air Pact is. I'm going to show you and describe to you the domain and the grid system that it operates on, and show you the framework, the cartoon of everything that goes into Air Pact. I'll introduce you to the Air Pact website, and I'll have some comments. So Air Pact is an automated, which is to say computerized system for predicting air quality for 2 days for the Pacific and Inland Northwest, runs overnight each day. Air Pact calculates the physics, the chemistry of air quality with a bunch of different processes, including emissions, dilution of air pollutants, the chemical reactions, the chemical aerosol physics, removal processes, such as dry deposition and rainout or wet deposition. It produces then estimates of the pollutants by taking all these things into account. The primary drivers are going to be pollutant emissions and meteorology. The emissions that we deal with are calculated using fairly detailed spatial databases for land use, vehicular traffic volumes, industrial emissions, and natural emissions, including the biogenic emissions and wildfire emissions. System also has built-in performance tracking. So on the left is the elevation map of the Air Pact domain. So you can see that it encompasses Washington, Oregon, Idaho, and parts of surrounding states and provinces. On the right, the land use land cover map. So this is, the system is referred to as an Eulerian system. It operates on a grid, checkerboard of 4 kilometer by 4 kilometer grid cells. So that's 258 columns from west to east, and should be 285 columns west to east, and 258 rows from south to north for about 73,000 cells in the surface layer. We operate in 37 vertical layers of the atmosphere, and for every one of those grid cells, solutions have to be found to the relevant air quality equations. This is a cartoon of the system. The biggest box in the middle is the Community Multi-Scale Air Quality Model, or CMAQ, which has been managed into existence by the EPA over many years. Feeding into that from the left, we have from a processor called SMOKE, that's another acronym. We have all these different kinds of emissions that get calculated and get integrated and fed into the air quality model CMAQ on an hourly basis. You can see around SMOKE, we have point and area sources, we have mobile emissions, we have fire emissions. Fire emissions come from satellite detects and then are processed as point sources into the emissions processing. We have biogenic emissions from vegetation and soils. The meteorology that drives the model is from a numerical weather forecasting system called the Weather Research and Forecasting Model, or WRF, and that we use the WRF model results that are generated at the University of Washington's Atmospheric Sciences Department. The boundary conditions on the 4 boundaries, north, south, east, west, that may flow into our domain and therefore affect air quality. We get those from a global model called the Whole Atmosphere Community Climate Model, operated at NCAR, the National Center for Atmospheric Research. And then each day's ending conditions are the beginning conditions for the next day on our modeling grid. So that's the skinny on how this system operates. So there I'm showing you the website for Air Pact. You could certainly just search for Air Pact. On the website, you find viewers that allow you to view animations of the hourly meteorology, the hourly emissions projections, and our hourly results for the pollutants. Mostly people care about a few pollutants, ozone and particulate matter called PM 2.5, which would be, for instance, indicative of smoke, and carbon monoxide. And so we show those in animations, as well as showing curtain plots of the boundary conditions for those and some transects across the domain for those. We also have a section devoted to performance plots showing how the forecast performs by date for specific monitoring sites, and also monthly statistics of bias and error. Soon we hope to be showing a bias corrected 24-hour daily average PM 2.5 Air Pact forecast, where we're doing corrections to the forecast based on recent results. So this was put together August 22nd, and this is the home page. And if you would go into the today's smoke forecast over here, you would get an animated graphic that shows you our forecast for PM 2.5. This one below that is the Air Pact 5 imagery in general, and the performance charting is here. Oh, and here is that bias corrected product that we've been trying to get out here recently. Lots of things to explore. Over on the left-hand column, there's an introduction to Air Pact. If you want to learn about it, you would go in there and give you various ways of looking at what Air Pact is, how to look at the results. So this is the PM 2.5 results for Friday, 8/21 at 1 p.m. There's little symbols that show the locations of the fires, and you can see some of them are producing predicted smoke plumes being transported toward the northwest in general at this hour of the forecast. And here's one of our performance charts for a location in Spokane. And there are many monitoring sites such as this that you can look at. So you can see the top graphic is for the PM 2.5 forecast, and the monthly mean, and the next one down is the monthly max PM 2.5. And you can see the model does a fair job over most months of, say, 2017 in this case, I'm looking back at. But when we get into the wildfire season of months of July and August and September, the model performance is much worse. Wildfires are very difficult to forecast in a reasonable manner. So, few thoughts. We don't model drought per se, obviously, but drought conditions of stable high pressure, low winds, low humidity, and lack of precipitation are optimal for wildfire, and thus for PM 2.5 pollution episodes. And for formation of ozone. So those are pollutants that we are particularly concerned with being able to forecast. Also, air quality, air pollution cause feedbacks to meteorology, changing the radiation fields and the vertical temperature profiles. That is something that most weather forecasting does not account for very fully. There have been some movements in that direction with the WRF operation at University of Washington, where they are now integrating in some radiation or some aerosol data to affect the results. So there's some feedback represented there. So, and if air quality and drought interactions are of interest, then maybe Air Pact or other air quality forecasting systems might be of interest to people concerned with drought. So I'll leave it at that. Thank you.
Thank you. And now we'll go over to our final speaker, Dave Peterson.
Okay, thank you, Holly. And do I have control of the screen, or are you going to advance these?
I'll be advancing it.
Okay, that's what I thought. Just wanted to verify. Thank you.
Thanks.
And boy, I really have to thank our other speakers this morning, because the background they gave on climate and fire and smoke was just a wonderful preparation for what I'm going to talk about here. And I really appreciate the excellent science that went into those presentations. So I was asked to speak about a paper that we published earlier this year that had roughly the title that you see on the screen here. Next. And that was a paper that was published in the journal Fire Ecology. The lead author on this was Dr. Jessica Halofsky, also worked with Professor Brian Harvey at the University of Washington. And we tried to synthesize a huge amount of information that we are familiar with relative to climate change, fire, and how that might affect the future of forests and fire regimes throughout the Pacific Northwest portion of North America. And that work was supported by the Northwest Climate Adaptation Science Center. So this was not new science per se, but it was the first time that such a large synthesis of the literature and an evaluation of its impacts on the future were made. Next. So I really appreciate the previous discussions on the effects of drought on wildfire, because that is really the focus of my presentation here. I found that it's very instructive to look at some of our past drought years in order to understand the relationship between drought and wildfire in the Northwest. So if we go back to 2015, which was essentially a record drought year for much of the Northwest, very little snowfall, very dry summer, there were 1.7 million acres burned in just the two states of Oregon and Washington, and there were 9 million acres burned in the western U.S. So this is really what we might call a big fire year. And you can see the smoke swirling around in this, this satellite photo on August 2015. Next. Let's go forward to 2017, another drought year. Now in this case, we had, as I recall, a relatively normal winter precipitation, but there were very dry, it was a very dry summer. And it's the summer drought that counts. I know that I often get questions from people about, you know, how the effects of winter precipitation are going to manifest themselves for wildfire. And I like to remind them that it's really what happens in the summer that counts for most of our fire-prone areas. So in 2017, 856,000 acres. Next. 2018, 870,000 acres. So if we take just these 3 years alone, that's over 3.4 million acres. So that's a significant portion of the landscape, a significant amount of area burned, and a lot of smoke during those years. Next. What we're finding with this increase in area burned over the last 30 years or so is that we're starting to get areas where fires are essentially running into each other on the landscape. This is a map of southwest Oregon, where 3 major fires have occurred since 1987. And if we look at that area in the very center of the screen that's red, 3 fires have occurred over a 30-year period in just that particular portion of the landscape. Next. Here's another map of southwest Washington. The big mountain there in the middle is Mount Adams. This is mostly on the Gifford-Pinchot National Forest. And we see that there's one area, again marked in red at the lower part of the screen, that has burned 3 times since 2008. This sort of reburning is pretty much unprecedented in the fire ecology literature, and it suggests that there might be some things happening that have not occurred in the historical past for fire. Again, promulgated by drought, perhaps. Thank you. And next. We can't talk about fire alone in looking at disturbances across the Northwest. Mountain pine beetle has been essentially the poster child for climate change over the last 3 decades. Over 50 million acres of tree mortality throughout Western North America, and big areas in the Northwest affected, as you see by that brown area there. Next. So we really need to be aware of this interaction of different factors in terms of what we can expect for future fire regimes and disturbances in general. So if we look into the future now, and we talk about water balance deficit in the western US in this case, and we can focus in on the Northwest, we see that there are some areas where deficit will be pretty significant in the future, including some of the areas that are currently burning in the western US, which is in Oregon, Northern California, and Colorado. We see some of the darker brown colors are where, in fact, this summer, we're having significant droughts and significant wildfires. Next. And if we look at just one thing, fire danger, this is a specific parameter that's used to express the potential for fire to occur. And that little sign of Smokey the Bear that you see with the dial on it is actually a real thing. It has meaning. High has meaning, very high has meaning, and so forth. And very high suggests that we will have a very high potential for fires to occur and that they probably won't be controllable. So what we see expressed in this map is the future for Washington and Oregon and part of Idaho in terms of the number of days when fire could potentially occur. Doesn't mean it will occur, it just has potential. There's a lot more orange going on later in the 21st century than there has been in previous centuries. And so this suggests that there will in fact be more fires in the future. Next. I know that's not exactly rocket science, but I think it's instructive to be able to quantify it. So what does all this mean for our forests? Next. We expect that there may be more of these reburns. Remember that those maps that I showed you of Washington and Oregon? Those burns may occur so frequently that some of our forests will have some difficulty regenerating. This is a photo from the south flank of Mount Adams. Next. We also expect that having more of these large crown fires will create big patches of younger forests. So in general, the forest landscape will look younger, trees will be smaller, the patches will be somewhat more homogeneous in nature than they have been historically. Next. The key to everything here is the regeneration stage for forests. Small trees at the soil surface where the temperatures fluctuate from very high to very low in a single day are very sensitive to weather and very sensitive to long-term periods of drought, particularly hot summers without rainfall. So that's where the competition will occur in the future in terms of which species and which genetic material survives into future decades. Next. I mentioned earlier this interaction of different stressors. So this interaction of drought, fire, and insects will probably have some interactions going on, not all of which we understand at the moment, but we think that each of these will be occurring more frequently and at larger spatial scales in the future, and that could create some interesting tipping points and surprises that we haven't seen historically. Next. We anticipate that forest species composition will change, that the forest structure will change, and in some cases, particularly at lower tree line, we anticipate that forests may transition to non-forest species, shrubs, grasses, and probably quite a few of our invasive and non-native species as well. Next. So what can we do to manage for greater resilience in these forest landscapes in the future? It's kind of a daunting task, but fortunately there are some general management strategies that we can implement that should help us. Next. First of all, diversity is almost always our friend. If we can diversify the forest landscape at different spatial scales, in terms of the age of vegetation, the structure of vegetation, that will confer some resilience. We can also orient the location of fuel treatments and other kinds of vegetation treatments to perhaps modify fire severity and spread. An example is simply doing thinning of very dense forests and implementing fuel treatments across fire-prone landscapes. Next. This is something that's already going on, managing stand density and fuels. If you have dense forests like you see in the upper photo there, there's simply just too many trees trying to pull up too much water. So those trees get stressed, they will perhaps become less vigorous, and some may die, as we've seen in the 2015 to 2018 drought period. Even in Western Washington, Western Oregon, there's been a lot of tree mortality. So if we remove surface fuels, understory fuels, that reduces fire intensity. But the key is to do this at a large spatial scale across large landscapes. And we need to have agencies, private lands, tribes, everybody working together to do this at a large enough spatial scale to actually make a difference in fuel reduction and fire spread. Next. Also, I know that a lot of people talk about fires being catastrophic and that these things are awful, and they may in fact be challenging socioeconomically and ecologically. But there are also opportunities. There are opportunities to start to implement other kinds of management, perhaps altering species, perhaps altering the genetic material of species that we plant. And also it's an opportunity to do some experimentation. You know, if we keep doing things the same way we've done in the past, we'll keep getting the same results. And we see that things are going to change so dramatically with future climate and more droughts that we need to start thinking about doing things differently. If we have vegetation management plans written and approved in anticipation of if, and not just if, but when these kinds of big fires occur, then we can hit the ground running, start doing some things differently, and hopefully increase our pace of improving resilience across the landscape. Next. So just to conclude, we know the climate's going to get warmer. This frequency and duration and extent of droughts increasing in the future is a real worrisome factor to me in terms of how things might change in our forests. We expect that we'll have fires burning over a longer period of time, increased fire frequency, and increased area burned. We expect that we will have more younger forests in the future and that the distribution and abundance of species might change significantly. But there are some options for building resilience. The key is that we need to get working on this soon. You know, if we wait until 2050, 2060 to really change how we're doing things, it might be too late for some parts of the landscape. And again, this point of collaboration is critical. We need to have everybody working together to implement things in a timely way and do it in a consistent manner across large landscapes. Next. Here's some links that you can check if you'd like. There's the published article that I've talked about today. If you like a more visual impression of what I've talked about, you can look at this story map. I think it's done quite well with lots of photos and maps to illustrate the points I've talked about, and even a podcast, which was done by the journal Fire Ecology. I put my email down here at the bottom. Anybody who's participating in the webinar today is certainly welcome to contact me, and we can discuss any of these topics further. Thank you.
Thank you very much, Dave. We now have a few minutes for questions. So any questions you can put either in the question or chat box, and we will get to those. The first two questions are for Jeremy. So will the wind shift pull smoke up from California into Washington? I'm going to unmute your line, Jeremy. Or maybe you need to.
There we go.
There you go.
I think I'm unmuted now. So can you repeat the question again?
Yes, so will the wind shift pull smoke up from California into Washington? You showed us two figures with the shifts in wind. I wasn't sure if one of them is going to start, one of the question asking if some of that's going to get pulled up from California or not, maybe into eastern Washington.
Yeah, well, we're already seeing some of that high level smoke getting pulled up into especially southeast Washington and North Idaho. But we're not going to be seeing a significant southerly surge where we would see a big smoke intrusion. So as we see the winds shifting around to the northwest by next weekend, we'd be paying attention to smoke from fires up in British Columbia, because I know there's a few fires burning up there, as well as any local fires, but we'll just see a general change in the smoke transport across the whole region as we get into that change next weekend.
Okay, thank you. And the next one is also for you. What do we need to know about the changing nature of ENSO based on the prevalence of how much elevated ocean temperatures in the Eastern Pacific, i.e. baseline blob? Is there any signal of changing ocean currents altering the variability of the jet stream?
Well, from what I understand and what the Climate Prediction Center has discussed as well, is that typically it's what happens in the tropics in the central eastern equatorial Pacific that drives the mid-level circulation. So the changes in the jet stream and the weather patterns are more tied to what happens in the tropics, and the warm water in the North Pacific is more of just a reflection of the patterns that are being driven by the tropics, and that it's not the warm water in the North Pacific that is causing the atmosphere to respond and give us a different pattern.
Thank you. There's a general comment of just thanks to everyone. And then another question for Jeremy. Have you purchased your season ski pass yet?
I have not. So.
Okay. The next two questions are for Dave. What are other fuel treatments besides thinning? And how does thinning change the risk of fires if it requires logging roads?
Yes, that's a good question. Thank you for that. In many of our dry forests that occur on the east side of Oregon and Washington, these are forests that have not experienced fire for many decades. So they're now in kind of a fire deficit compared to what they were historically. So that's resulted in two things. One is that the understory has become more dense than it was historically, and also the fuels have accumulated on the forest floor. So the way this works physically is that the heat released from the surface fuels provides most of the energy for a fire and helps to create the crown fire. The density of the forest helps to carry that crown fire horizontally across the landscape. So you need to reduce both of those in order to reduce the risk of a crown fire occurring. If you do just one or the other, that really won't make much of a difference. But we know, very, very good empirical data that if we do both of those, we don't stop fires, but we reduce the intensity of those fires and the rate of spread. And having, in almost all cases, those landscapes already have roads in existence. So typically new roads would not be created to do thinning. We have thousands and thousands of miles of road already, and they probably don't increase the risk very much compared to current sources of ignition.
Okay, you have two more questions, Dave, and I think we have less than a minute left.
Okay.
How have invasive species impacted areas with frequent burns? Are there more significant differences from areas that only burned once in recent history? And then the other question is about engaging the general public, but I'll let you answer that first one.
Okay, so for the invasive species, they tend to affect our shrubland systems more than forest systems right now. So things like cheatgrass, knapweed, the annual plants in particular, they really add to the rate of spread of fire through these landscapes. So some of our sagebrush and other shrubland systems are burning much more frequently than they did historically, which is creating more mortality in some of those native sagebrush species, for example. Affects forests a little bit, but not quite as much. And what was the second one, Holly?
The second one is, how do you envision engaging the general public when shifting forest management strategies, such as species reforestation choice?
Okay. Well, that's a long topic, potentially, for an answer there. I think in a general sense, strategic sense, the more that public agencies can do to engage local communities to become part of solutions and mitigation, the better. So it doesn't become an us versus them thing, or just a matter of agencies saving communities by putting fires out. We need to engage local communities early and often in terms of preparing and not just being a recipient of fires and other kinds of disturbance effects. So there's a lot more. If the person who sent that question would like to discuss it further, they can feel free to email me. There's lots of good things going on already.
Great. Thank you very much, Dave. And another general thank you for everybody and great speakers today. So I want to thank everyone for joining us today and for our presenters for giving their presentations. A recording of this webinar will be available on drought.gov later this week. And if you would like PDFs of the presentations, you can email Britt Parker. Her email's at the bottom of the slide, or each of our speakers that are posted here. And also please mark your calendars for our next webinar on the 26th of October. Thank you very much, everyone, and have a great day.